Hey everyone. Well, today we're going to be talking about forming compounds. And the question that we ask is, how do compounds form? Well, compounds form because the outer electron or outer electrons, plural, interact with other electrons from another element. They might even interact with an electron from the same element, all right? And then a bond is formed. So last class we talked about ion formation. Well, for things to become a compound, they need to be an ion. What that means is their electrons are either going to be their outer electrons, and these are called valence electrons. Their valence electrons interact. Now, if an electron is gained, that element starts to become negative. And when it gains that electron, well, it gets that electron from somewhere. And when it gets it from an atom, that electron now is going to be positive, and therefore they're going to attract. And the first type of compound we're going to talk about is ionic compound. And ionic bonding is between a metal and a non-metal. And if you look on your periodic table of elements, this metals are on the left and non-metals are on the right. Now, if we take an example here, we've got sodium and chlorine, and we've got Na plus and Cl negative. Well, what that means is our sodium has an electron it wants to give away, therefore it's going to become positive because it's going to have more protons than electrons. And our chlorine atom, it wants to gain one so that it has a full valence shell, and it's going to become negative because it's going to have more electrons than protons. So sodium has 1 electron in its outer shell, chlorine has 7 electrons in its outer shell, so sodium donates its electron to chlorine. Chlorine comes along and steals it, let's be honest here. So one gains electrons and the other loses. So steps for writing Bohr ionic diagram, bonding diagrams. So for each individual Bohr diagram, so we need to draw it, and we're going to draw it so that it has a charge. All right, so you'll notice that this electron came right over there. And what we're going to do is we find out how many electrons the atom needs to donate or receive. Then we redraw our Bohr diagram with a new number of electrons. Now we're also going to put large square brackets around these elements. Now this is ionic bonding, we do that. So, and we have our charge right at the top. And what happens is they're going to be attracted to each other to create NaCl. All right, now let's try one more. We've got potassium and we've got fluorine. Well, potassium is a metal and fluorine is a non-metal. So if we draw our Bohr diagram, we've got K, and we've learned that our first shell always can only hold 2 electrons. 1, 2. And we've got 1, 2, 3, 4, 5, 6, 7, 8 in our second shell, and potassium has 1 extra one. And so K plus, meaning that it wants to give one away so that it becomes positive. All right. Now we're going to add it to a fluorine atom. And a fluorine atom has 1, 2, 3, 4, 5, 6, 7, 8, and 9, and it wants an electron to come right in over here. And we're going to get fluorine negative, meaning that it gained an electron. All right, it gained an electron to have a full valence shell. Well, what happens now that we give that electron away and then one gains it? Well, we get a Bohr diagram that looks like this. We have our K, and now we're going to only have 2 shells, and they're both going to be full. And it's going to have a set of brackets around it, and because now it has 1 more proton than electron, it's got a positive charge. And right beside this, we're going to have a fluorine ion, and it's going to have a full valence shell as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And because it gained 1 electron, it's got 1 more electron than proton, it's got a negative charge, meaning that one potassium ion satisfies one fluorine ion as well. All right, let's turn over the page for me. And we're going to talk a little bit about covalent bonding. Well, covalent bonding is a nonmetal plus a nonmetal. And atoms of nonmetals share electrons. Now that's the difference between ionic and covalent bonding, is that covalents share. It's like cooperating. And they share, and they're with other nonmetals. Now both atoms are attracted to the same pair of electrons. Remember that protons are positive, electrons are negative. So let's take a look at this. We've got an H, an H, and an O. Well, that's going to make water. And we've got our H has 1 electron in its valence shell, and our oxygen has 6 electrons. Well, it wants 2 electrons so that it's satisfied. Those are the hydrogen atoms. And the oxygen atom wants 8 electrons to be satisfied. So we draw each individual Bohr diagram. We find out how many electrons the atoms need to share. And in this case, both hydrogen atoms have 1 to share, and the oxygen wants 2. Then we redraw the Bohr diagram, this time with the atoms sharing the electrons. And remember, we may need 1 more to make it work. So let's try fluorine and fluorine. Well, fluorine looks like this. It's got 1, 2 shells, and it's got an electron here. 1, 2, 3, 4, 5, 6, 7, 8. And it's got 9. And finally, we're going to add another fluorine to this. And it's going to look exactly the same. And look at that. Well, they each need 1 electron to be satisfied. So therefore, they're going to share, and it's going to look like this. And they're going to share those 2 electrons, this one and this one, so that they both have a full valence shell. So they both have 2 in the middle and 8 now in our valence shell. So they're both satisfied. And if we wrote the formula for this, we get F2. All right. Well, have a good rest of the day, and we'll see you in class.